Recording in progress.
Very good evening, everyone. Am I audible? Okay, so did you all solve the questions? Did you all solve the questions that I gave you yesterday? Okay, so we did it up to third. What is the answer for the fourth? Yes, can anyone tell me what is the answer for the fourth one? Okay, I got one response. That is okay. Okay, two responses. What about the remaining class? Yes, did only two people are interested in this class and the remaining are like sleeping? Okay, so let's start on with this question. We will see how it is getting solved. So first of all, it is given that your a is equals to 0 and I is equals to n, while I is greater than 0. Okay, so for the first step, your I will be equals to n, yes or no? It will go in and increase the value of I and like increase the value of a and decrease the value of I2, I divided by equals to 2. So I now will become n by 2. Yes or no? In the coming step, it is going to become n by 4. Yes or no? Then in the next step, it is going to be n by 8. Slowly, since you can see it is getting divided, there will be a point when this division will reach to 1. That is, I value will reach to 1. Yes or no? Yes. Now, what is the series that is getting formed? For your first iteration, you have your I equals to n. For your next iteration, you have your I equals to n by 2. For your next iteration, it is I equals to n by 4. So you can write here it as a series that is n plus n by 2 plus n by 4, and it will continue up to 1. Yes or no? Yes. Is anyone familiar with these kind of series? Is anyone in the class familiar with this kind of series? Okay, forgot. It's geometric progression. Correct, Vishnu. So you all know that this will be a first element, which we call it as an A. Okay, those who don't know about the GP, the first element of the series, we take it as an A or the initial element. Then we need to find out R. R means the difference between the two numbers. So what will happen? We divide the second element by the first element. Dividing these, we are going to get our R equals to 1 by 2. You all can see that this is the decreasing GP series. Yes or no? Yes. So its formula is, I will write the formula first here. It is A 1 minus r to the power n divided by 1 minus r. Clear, everyone? Anyone in the class who is not getting this formula and the GP concept? Okay, if everyone is getting it, then here I will put the values. Your A or the first value was n. Your R is 1 by 2. N you don't know, right? Let's keep it as an n divided by 1 minus 1 by 2. Okay. Now this 1 by 2 is approximately 0.5. Yes or no? Everyone are you able to follow? 1 by 2 can be written as 0.5, right? And then 0.5 to the power n, even if it is 10, then you're going to get some number like 0.0000 somewhere around some 5 you will get, like it will be a very small value. Yes or no? Here also 1 minus 1 by 2, it's approximately 0.5, which is again, you can take here it as like take the LCM, you will get here. As of now, I am just ignoring. I am ignoring this term as it is going to give you very small value. So I'll come here and I'll take the LCM downside. So it will become 2 minus 1 divided by 2. Solving it, I'll get here. I will take 2 on the upside. So it will become n by 2 because in the denominator and upside, it will become 1 and 1, which will cancel out. So overall, you will get 2n. Yes or no? So if I write the time complexity for this, it is going to be order of n. Clear, everyone? How many of you solved it like this way? Okay. Those who didn't, just take it. Those, how many of you at least solved one question? I want to know that. Okay, Vishnu did. Kishan tried, Bhuvnesh tried, Aman solved. Okay. 4 people. Abhijit, what about you? Ashish. Okay, Gaurav tried. Kishore, Mohan, Prashant, Rohit, Sai, Mani, Swati, Vaibhav. What about you guys? Okay, I'll solve this fifth question afterwards. Let's focus first on our sixth and seventh question. Okay, can anyone tell me the time complexity for sixth question if you have figured it out? Yeah, anyone who tried the okay order of n, n log n. Okay, Let's see. For I equals to n, how many times your J loop is going to run? N times. I equals to n means indicate only one iteration. Don't get confused. For I equals to, every time it is getting divided, it will become n by 2. How many times J will run? It's less than I, right? So it will run up to n minus 1. Oh, sorry, n only, because from 0 till n minus 1 will be n only. Correct. For any doubts? Okay. Then for the next time, it is going to be I equals to n by 4. And it is going to run for n by 4 times. Everyone, are you getting this? Okay. Just a minute. Hello. Yes. So you all can guess now that how your J loop is going to continue, yes or no? Are you all getting this? Just a minute. Okay, got it. And okay. So did anyone now figured out what is going to be the time complexity for this? Why same like 4?
Because it is same thing like n half and by 4
See,
it will go into
in the fourth question, only one loop was running. Okay, so initially it was n, then n
uh,
by 2, then n by 4. Are you getting this?
okay.
This was the value of I, and this was considered as one iteration. Okay, this was your
Okay.
one iteration, this was your second iteration, and similarly it was continuing. Getting this?
Now I got it. Yeah, I'm
Yeah.
clear now.
But here what is happening? Sorry. Yeah, here you can see the single J loop is running for n times. Okay, then the single loop for the other time is running for n by 2 times. Similarly, the another one, it is running for n by 4 times. Are you getting this?
Yes.
Okay, then. So everyone must have figured it out that roughly this loop will ultimately go up to 1. You can say this is following the GP series. So its complexity is going to be order of n. Yes or no? I am only talking about I loop. But inside this, in the worst case, J loop is running for n times. So outer loop running for n times, inner loop running for maximally n times, it makes its time complexity as n square. Clear, everyone? Okay, so its time complexity is going to be order of n square. If anyone is facing any doubts or any questions, they can just unmute and ask. Next is, yeah, for this question, anyone figured out the time? Guys, be quick.
Hello. Hello.
Yeah, man.
Yeah, ma'am. What is the final answer of that question?
The
Order of
final answer is order of n square. Yeah.
uh, order of n square for J loop, right?
Order of n square for?
J loop. The
No,
second.
not for the J loop, Aman. For the entire. See, your for I equals to n, how many times your J is running?
N times.
N times. For I equals to n by 2, how many times it is running? N by 2 times, right?
Yes,
You
ma'am.
can see your I loop is following the GP series.
Yes, ma'am.
So overall, it is going to give you order of n time complexity.
Yes, ma'am.
And internally, in the worst case, you can see that J is running for n times.
Yes, ma'am.
So that's why it is n for the outer loop multiplied by J, like multiplied by n of the inner loop.
Yes,
Clear?
ma'am. Yes, ma'am.
Sure?
Yes, ma'am.
Okay. Now I want to know the answer for the seventh question. How many of you did it? I cannot see any answers so far. Okay. Let's see it, how it can be solved. For your I equals to n by 2, how many times your J loop is going to run? J will run for initially 2, then 4, then 6. Sorry, not 6 actually. For 8, 16, and I can say that it is 2 to the power k. Yes or no? Yeah. Like this 2 to the power k should be less than or equals to n, and it will continue till then, right? Coming on to the next part, when your I will be like for the next time, what will happen? It will become n by 2 plus 1. Yes or no? Because it is incrementing linearly. And for that reason also, it is going to run for 2, 4, 8, 16, and up to 2 to the power k. Yes or no? This is a GP. Yes or no? Everyone, are you able to follow this? The J loop is following the GP every time. Okay, so its formula will be, I'll just write it. You can see, no, let's see now what it is going to come. It is an increasing GP. So now it will be like R to the power n, A into R to the power n minus 1 divided by R minus 1. It will overall become A is 2, R is your 2 to the power. What should be written here? I am considering that it is running up to k times. So k minus 1 divided by 2 minus 1. Okay. And what about the outer loop? How many times it is going to continue? How many times your outer loop is going to continue? Can you tell me the complexity for outer loop? Outer loop is running linearly from n by 2 till n. So overall, we can write it as n. Okay, n time complexity. Correct. For the inner loop, you can see that it is going to be 2 into 2 to the power k minus 2. Ignoring the constant terms, you will be getting here n for the outer loop multiplied by 2 to the power k for the inner loop. This is going to be the time complexity. For this time, we are not going to find the value for k because we don't actually know where your end is going to be ended. Okay. Are you all getting this? Or you can do it like this, assuming 2 to the power k will be somewhere equals to n. Sorry. So you can take log on both ends. Here you will be getting k equals to log n. So what will happen? It will become like n into what is your k value? Log n, right? Everyone, are you able to follow this? So this will cancel out and overall it is going to come out as n into n, which is n square. Clear? Okay. Now coming on to our last question. Just yeah, for this, anyone figured out what is going to be the time complexity? I figure it. Good, Gaurav. Now see this. I am taking the best case scenario here, taking the ascending order array, taking j equals to 0. Your I is starting from 0. So here it will check. Is your j less than n? N is nothing but the size of your array. So 0 is less than n, yes or no? Yes. Then array of I is less than array of j. Your array of I is 1. Your array of j is also 1. Is less than or equals to? Condition is true or false? True, right? So j was initially 0, but now it will cut down to 1. Clear? And your I is still equals to 0. For the next iteration, it will again go into the while loop, and here it will check, is your j, just a minute, yeah. Now j will become 1. 1 less than 5, yes or no? True. Now here it will be like 1 less than or equals to 2. Is it true or false? False. So it will come out and go again into the for loop. Everyone, are you able to follow this? Sorry. Yeah. Yeah, my bad. And everyone else is sleeping. Thanks, Kishan. Your array of I is 1. Your j is 2. The condition is true. Again, it will enter into the while loop and increase the value of j to 2. Next time again, it will go and check if 1 is less than equals to 3. Again, it will be true and your j value will become to 3. Next time again, it will continue. Here inside it will be 1 array of I and array of j now will be 4. Condition is true. Your j becomes 4. Again, it will run and it will find that 1 is less than 5. So now when the next time it comes, the condition here will become false because 5 is not less than 5 and it will come out. Clear to all or not? Yes. For the next time, it will go up, increase the value of I. Okay. And I will now become 1. Will it enter into the J loop again? Now it will not enter into the J loop because J is still 5. Okay. So it will again go change the value of I to 2, then 3, then 4. Like it will continue up to n, and then finally it will exit the loop. Knowing both these scenarios, can anyone now tell me what is the time complexity for this? Kishan, how it is going to be order of n into n? Because you can clearly see that when I was like at 0, J completed its entire loop of n. And for the next time, it is not even running. Then how it can be n cross n? N cross n will be the case where your J loop is running for n times all the values of I. But it is not happening here. Yes, guys, you have to tell me the time complexity for this. Only one answer I have got so far. What about the remaining? Today, we will finish our time complexity. And tomorrow, I am planning to start on with stack and queues. So please don't delay it. Okay, so if it is incrementing without having anything inside it, then it has. Yeah, obviously it is not going inside the loop, then it will be order of 1, no? No, I am not going to cover custom collection because it is not a part of our course. Basically, your J loop is only running for n times once, and then it is getting stopped. Okay, you can take multiple scenarios for array if anyone having confusion. I'll give you the array values. Just a minute. You can take array value as or you can take a perfectly opposite case of it as 5, 4, 3, 2, and 1. Take these two cases and then identify what will be the complexity. As of now, its complexity, according to me, is order of n because inside this loop, J is only running for n times once, and then it is becoming order of 1. Hence, its complexity is going to be order of n. Clear to all? Guys, is it clear? Okay. Anyone having any questions, they can just clear it out right now.
Hello.
Yeah.
Ma'am, why are we not considering for I? for
We
the
are considering for I, right? But for I, you can see that only once the J loop is executing for the n times, yes?
yes, ma'am.
And the remaining times, is it even entering into the J loop?
No,
No. Hence, only one time n is getting executed now. So we cannot take it in a like variable way and say that its complexity is going to be n cross n. Are you able to follow this?
yes, ma'am. But I is also running from 0 to n.
Yeah, I is running from 0 to n. Then
Then why are
see,
we not
I
running?
is running from 0 to n. Okay. And one more n times iteration is happening inside the J loop. So overall, how many iterations are happening?
What is
Yeah, I'm not getting you.
overall two iterations?
See, overall, your I loop is running for n times. You are getting this.
Yes, ma'am.
In addition to that, your J loop is also running for n times, but only once. Is it running for multiple times?
No, ma'am.
No. So it is becoming a kind of addition operator instead of the multiplication operator. That's why I said its complexity is going to be order of n. Clear?
Yes, ma'am.
Yeah. Let me just write this question once again. Anyone figured out the complexity for the fifth question, by the way? Yes, guys. Anyone? Tried but didn't get. Okay, at least you tried. That's a good thing. This power function is going to take constant time as per the question. Here also some order of one time complexity code is going to get executed, and that's it. Okay, now let's please see. Your I was equals to 1. For I equals to 1, you will get something power, okay? I power k you are going to get. So for 1, it will be 1 power k, yes or no? I'll just write the value of power as well. Power equals to 1, like I equals to 1, so your power will become 1 power k. And your j loop is going to run for 1 power k. Getting this? Okay. For the next time when it will come, it is going to be like I equals to 2. Linearly, it is running. Your power is going to become 2 power k. And your j loop is going to run for 2 power k. Clear, everyone? For I equals to 3, power is going to become 3 power k. And j is going to become, like j is going to run for 3 power k. If I will continue this thing, up to n. J is going to run for n power k. Clear to everyone? Okay. Now, if we find the total of, yeah, right. Inner loop is following some kind of progression. Correct. So I will write here one power, like in, I will write here as an addition 1 power k plus 2 power k plus 3 power k up to n power k. Okay. So here I am assuming for the first equation k equals to 1. What will come as an answer then? If you will assume k equals to 1, then can anyone tell me the answer for that?
n into n plus 1 by 2.
Correct. Everyone, I hope you are getting that. Do the same thing for k equals to 2, k equals to 3, and k equals to 4. For this, I got the answer as or wait a second. Yeah, you will almost get it as order of n into n plus 1 divided by 2. Be quick and tell me the answer. Leave for 4 as of now. Just tell me up to 3. It is going to be huge because. Okay, for 2, I also got order of. It is going to be not order exactly, I should write. It should be like n into n plus 1 to n plus 1 divided by 6. For k equals to 3, for k equals to 3, it is going to be n square into n plus 1 whole square divided by 4. So if you all see here, for the first one, it is going to be order of n square. For the second one, n multiplied 3 times order of n cube. Here it is already n square. If this will be solved, again you will get n square. Overall, it is going to be order of n to the power 4. Clear? And one more thing to be observed. In this, it is n square by 2. Here it is going to be almost n cube divided by, since here it is 2, somewhere we will get around 3. Here we will get n to the power 4 divided by 4. Kishan, I hope you got this, that it is going to be n cube divided by 3. Because the maximum factor is going to be n into n square into 2n becomes 2n cube divided by 6, it is going to become n cube by 3. Clear? If it will continue for k times, it is going to give you, okay, this was for n, like for 1 you got n square, for 2 you got n cube, for 3 you got n to the power 4. So for k times you are going to get order of n to the power k plus 1 divided by k plus 1. Clear? Everyone, are you clear? How many of you are having the questions regarding this? Anyone having any questions? Okay, if no, then good. Then I'm going to give you the last activity for the time complexity. In this particular activity, your n is going to be 10 to the power 6. You have 1 gigahertz of processor, assuming that it is going to execute 10 to the power 9 instructions in 1 second. Okay. Again, here you just assume that one iteration is equals to one instruction. And one more calculation. 10 to the power 3, you all know it is 1000, is approximately equals to 2 to the power 10, which is somewhere around 1024. So they are considered almost equal. Clear to all? If I am giving you big O as n cube, you have to tell me the number of iterations and the time, considering n equals to 10 to the power 6. Okay. If I am giving you the big O as n square log n, then again you have to tell me the same things. Same thing go for n square, n log n, then n only, then comes root n log n. Root n, consider it as a square root only. Huh? And the last is you need to find the value for 2 to the power n. Don't consider n as 10 to the power 6 here. Consider n equals to 30 for the first time, and for the next time consider n equals to 60. And then find the respective answers for both of them. Clear? Okay. How many of you are confused with the activity? Yes, guys, you can say it. If can you please explain again? Okay. Gaurav, the question is, you have been given n equals to 10 to the power 6. Okay. So I am saying if your time complexity for the question comes out to be n cube, then what will be the number of iterations and what will be the time it will take? Okay, you already know that one instruction, like 10 to the power 9 instructions are getting executed in 1 second. Yes or no? So according to that, you have to find the time and iterations for all the time complexities. Up to here, you have to consider n equals to 10 to the power 6. For the last two scenarios, you have to consider n equals to 30 and n equals to 60. Clear? I want this table to be filled by you all by tomorrow. I'll just check the values, what you have got tomorrow, and then we will start on with the stack and queues. Clear to all? I'll discuss like tomorrow, some of the importance of constraints, like why constraints are given in the particular questions. And that's it. Okay, anyone has any doubt, or should I close the call?
Recording stopped.
Aman, you have any question?
No, ma'am.
Yeah, sure, we can solve. Yeah, Aman, say.
No, ma'am.
Okay, you don't have.
Recording in progress.
So we can solve for n cube. For n cube, the number of iterations will be n into n into n. Your n is 10 to the power 6. Total number of iterations will come out to be 10 to the power 18. Yes or no? Now, talking about the time, how much time it is going to take? These are 10 to the power 18 instructions or iterations. You can take it in any way. So 10 to the power 9 iterations or instructions takes 1 second. How much time 10 to the power 18 seconds will take?
2 seconds.
How much?
2 seconds.
2 seconds. Who is this? And I'm not actually getting. Okay, Aman. Aman, if you were there in the class, I told you all, if it is 2 into 10 to the power 9, let's suppose the value is, then what will be the value for this? The time?
2 seconds.
2 seconds.
Yeah, got it, ma'am.
Got it. If it is 3 into 10 to the power 9 instructions, then
3 seconds.
3 seconds. So now the value is 10 to the power 9 into 10 to the power 9 instructions. What will be the answer for this?
10 to the power 9 seconds.
Correct. Which you all know that you have solved. It's come out to be 13.7 years. Clear? So I hope every one of you got the idea what to be done. Yes, no. Okay, then I'll close the call for today and I'll see you all
Recording
tomorrow.
stopped.
Space complexity, Richa, it's not that of very much thing. It's simply like whatever extra space you take, that takes like comes under the space complexity. So it will be taught like in the coming questions. Okay, so don't panic about it. Okay, anyone else having any other questions? Yeah, we do have bitwise operators in our syllabus, but it is going to be our last topic of the particular course because like it's nowhere related to any other topic. Anyone else?
Ma'am, I had question about the fifth one.
Mm-hmm.
For me, it was O(n) into P. Should we call it as n square or should we call it as n into P?
Were you there in the class?
Actually, I had to jump off on 11:05, then I joined in.
Yeah, actually, I explained it that entire question. So you can go through once like this whiteboard thing. If you are still not clear, you can clear your doubt tomorrow. Okay.
Okay.
Yeah. Anyone else in the class having any other questions? Okay, then. Bye, everyone.